Got that written down? Okay. So, like we did yesterday, let's just go back a couple steps and see what we were talking about. In the first lesson, we learned that when you were to multiply like bases, who can tell me what did we do with the exponents? Yeah, Jawad. We added them. Great job. Thank you for that.
Wait, is our final going to be on this or on everything?
What's our test going to be next Thursday? Is it going to be just on Unit 7 or about everything? You guys don't listen at all, do you? Unit 7, thank you, Layla. Just Unit 7, yeah.
What are we going to get from here?
Okay. Do you have a question about this? Yeah, we'll get a study guide for our test.
Yes.
We'll get a study guide for our test. Okay? Can we do what we're going to do now?
Yeah.
Perfect. So in the next lesson, 7.2, this is what we talked about yesterday. We talked about dividing like bases, and we learned that when we divide like bases, now what do we do with the exponents? We subtract. Okay. So what we're talking about today is called the power rule. Everybody say power rule. Thank you, everybody, for saying power rule. And what the power rule says is when you raise an exponent to another exponent or power, and we'll see what that looks like in a second. Well, I mean, you can see right below what that looks like. But when you raise an exponent to another exponent, what do you think we are going to do with the exponents now? What would be the logical next operation for us to perform? Multiply. Give me a thumbs up. You agree with Ray. We're going to multiply these exponents. Daniel agrees. That's good. Hiba agrees. Hiba gets it. Zach maybe agrees. Jawad. It's exactly what we're going to do. We added the exponents, then we subtracted. Now we're going to multiply the exponents. Anyone want to take a guess what's next? No? Thank you for your honesty. All right, we're just going to multiply them, right? So this is what power raised to another power looks like. 3 to the second raised to the third. Okay, so 3 to the power of 2 is being raised again to the power of 3. Give me a thumbs up if you see that. It's like 2 little exponents. You guys alive? Awake? No?
Yeah.
Okay. Well, I'm going to talk, and then if you want to listen, you can listen. Hopefully this makes sense. It's pretty straightforward, right? We take these two powers, and essentially all we're doing is distributing them. And when we distribute, we know, obviously, that we multiply, right?
Like distributive property.
That's right. So the 2 gets multiplied by the 3.
Oh.
2 times 3 gives me 6.
So we're not multiplying the 3?
No, the base stays the base, just like in the product rule and the quotient rule. That's a good question, yeah. Our base does not change. And we'll see why we can do this in just a second. Okay? Like I said, it's basically like you're distributing the outside exponent into the inside exponent. And when we distribute, just like when we talked about equations, when we distribute, we are multiplying, always. So like I've been saying, when in doubt, expand it out. If we want to understand why one of these rules works, we can just expand out the problem and see exactly why we can take this shortcut. So if I have 3 squared to the power of 3, right? That means I'm going to take whatever's inside my parenthesis and I'm going to write it out how many times? 3 times. Right? So 3 squared times 3 squared times 3 squared. Everybody see that? Yeah? Well, now I'm going to expand each of these. How can I expand out 3 squared? 3 times 3 times, again, 3 times 3 times, again, 3 times 3. Okay, see how we did little 2 levels of expanding out? Well, how many 3s do I have in total? I got 6 of them. Oops. I got 6 of them. So because I have 6 3s, if I was going to bring all those 3s together, I could write it as 3 to the power of what? How many do I have again? 6. So I can write it as 3 to the power of 6. Is that the exact same answer we got just by multiplying and distributing those exponents to each other?
Yeah.
Yeah, 3 to the 6th power. Give me a thumbs up if that makes a little bit of sense. Okay. Good. I told you we were going to go quick. When you get the second piece, we're going to do the first 2 of them together, so just glue it in right now and wait patiently for everyone to get on the same page, and then you guys are going to take some time and do the other ones. But the first 2 I do want to do together, so just hold off on running through them. Yeah.
Coaching Mr. Williams. Me either.
It's alright, I know he looks white. Go ahead, Zach.
Yes.
Because he didn't open the empty blue stick and the thing popped out. Oh my, I guess you can. Bro, it's funny.
No, I don't. Ew, why is your hair on it? Oh, no. Poor glue stick.
Did you not just see me go?
All right, let's take a look at this first example. Example 17. What's my base in example 17? What's my big base on the bottom? What is it? X. Okay, what is x being raised to the power of here? 3 and 4. So I'm taking x to the third 4 times. If I have 3 of them 4 times, the only thing we need to do is multiply 3 times 4. Well, what is 3 times 4? 12. Can I simplify x to the 12th at all? No. It's easy as that. Right? But if I look down on number 18, what am I raising 3 squared to the power of?
2 and
Negative 3, right? 3 squared to the negative third power. Well, what am I going to do with 2 and negative 3 in this case? We're going to multiply them, right? We're doing the same thing. 2 times negative 3. And I want to put that negative 3 in parentheses because I don't want to confuse what I'm doing, right? If I don't put the parentheses there, my brain might accidentally tell me to subtract, especially with what we talked about yesterday. So this just makes it nice and easy for me to see, hey, I'm definitely multiplying. And what is 2 times negative 3? Negative 6. Is that my final answer? No, right? We still need to make this exponent positive. Well, how can I turn this exponent positive? What do I need to do first? Put a 1 under it. Now that it's a fraction, what can I do with that fraction? Flip it. And when I flip it, what happens to my exponent? It becomes positive. 1 over 3 to the 6th. Right? So give the last 4 a try on your own. We'll take like 5 minutes, see how far you guys get. Now again, on number 19, I'm pretty confident you guys can multiply 5 times 2 in your head. I still want to see at least this step right here. So what we see in number 17, that's what I should see in terms of showing your work, okay? But give the last 4 a try. I know there's a fraction in there. That might trick you a little bit, but keep in mind for negative exponents, see what you can come up with for those last 4. We'll do 4 minutes on that. Looks like we're all done for the most part, so let's keep it pushing. So number 19, 7 to the 5th, raised to the 2nd power. Okay, if I distribute that 2 to the 5 and multiply them, what's my new power of 7 going to be? Well, what's 5 times 2? 10. Is that what you guys got? Give me a thumbs up if you got 7 to the 10th power. Okay, good. Great job. Nice and simple one, right? Example 20, I'm distributing the 1 to the negative 3. Okay, so what's 1 times negative 3? Negative 3. Is that my final answer?
Yeah.
Do I want a negative exponent in my answer? No, right? So what can I put underneath that A? A 1. And then what can I do with it? Flip it and make the exponent positive. 1 over a to the 3rd, right? Now with example 20, do I really need to distribute that 1? No, because anything to the 1st power is just what? Sorry. Anything to the 1st power is just itself. So if I don't even put this 1 here, look, it's still a to the negative 3, a to the negative 3. So in the same way we talked about on the worksheet with that, was it like x to the 0th power or 2 to the 0th power, whatever it was? If you can see a shortcut to make your life easier, that's great because that shows you're using what you know about this stuff to your advantage. Here I got 10 to the 10th power raised to the half power. That's weird. What am I going to do with that 1/2? Multiply it, or in this case we're going to divide it, right? If I have 10 times 1/2, that's the same as 10 divided by 2. Well, what's 10 divided by 2? 5. Can I simplify 10 to the 5th pretty easily? Yeah, we talked about it. How can I write out 10 to the 5th power nice and easy? Yeah, Daniel, you remember?
Just put 5 zeros.
Yeah, it's a 1 with 5 zeros. Anytime we have 10 to the power of something, that power tells me how many zeros come after the 1. That's all. So what number is this that I'm looking at here? Is that 10,000? Is that 1,000? 100,000. So from the right to left, I'm going to go 1, 2, 3 spaces and put my comma. There's my answer right there, 100,000. It's really important we understand these powers of tens because at the end of this unit, the last couple lessons, it's all going to be about powers of 10 like that. Okay? Anybody get 10 to the 5th on 21? Jawad did, Gianni did, Daniel did, Caleb did. Good, great. A lot of us did. And example 22. Ooh, I got double negatives here. What happens when I multiply a negative by a negative? What do I get? We get a positive. So if I distribute the negative 2 to the negative 3, negative 3 times negative 2, what is 3 times 2? 6, and a negative times a negative gives me, like we said, a positive. Right, so take a look at 22. If you ended up with 1 over 4 to the 6th, make sure we remember, hey, if I multiply two negatives, that's going to make a positive every time. Because my answer has a positive exponent, I don't need to put a 1 under it and flip it around. That's not necessary. I'm just done with that. Is it fairly easy for us to simplify 4 to the 6th power in our head? No. No, not really. So we're just going to leave it like that. Is that what you guys got? 4 to the 6th? Show me with your thumbs up. Who got that? Okay. Great. It's not too bad, right?